learners away. It gets learners away from the idea that they have to always have the same number of things in their category. And so forcing learners to not rely on those shortcuts and crutches that they've leaned into in the past is a positive thing. The next slide, on slide 3, I don't care if you all do that one, but if you notice that on slide 3, I've then intentionally forced learners to be out of their comfort zone and taken away a lot of the supports to what a parabola would be. What does it mean if D is a positive 25? And it's a sketch, it's not an exact picture, but what would it mean? What would a correct answer here be? And I think that's really important that we give learners that ability to construct math representations that may not have to be perfect. So Rochelle Gutierrez here is actually plotting points and probably calculated. Vihart just drew something that is crosses the x-axis twice. And then we have, you can see it on the overlay. You can see that people are calculating. I'll be honest, when I designed this and what I would think, I would be completely happy if a learner just did that. Because the idea is if D is a positive number, it has to cross the x-axis twice. Even if there was someone here, yep. Nailani Joshi here is doing the calculations, figuring it out for sure, right? And that's great, but that's not the point. The point is just, can you give me something that looks reasonable? There's also some other tools here we can use for questioning. So I'm gonna, not everyone has 2 computer screens, so not everyone may be able to see what I'm looking at on my screen compared to what you're looking at. So I'm gonna hit pause for a second. One of the really effective tools is this little icon up here in the corner, the picture. How many people have used and are aware of the camera icon and what it does? Or actually, if someone wants to tell me if they don't know what it does, because they don't want to spend time on something if everyone knows what the little camera icon does. Okay, perfect. So the camera icon is incredibly powerful for student questioning. Just click it. It says a snapshot was captured. And then we can come over here. This one is pretty approximately correct. And so I clicked it again, snapshot captured. And then I'm going to snapshot this one. So when I'm using Desmos in the classroom, when I find, you know what, let's do this one too. When I find student work, learner work that is particularly interesting for our conversation, I click on the work, snapshot it, and then up here in the top corner, there's the snapshots. It shows I have 4. I can drag the snapshots here, and I can create an album with it. And then I can hit pause, and I can have 2, 3, 4 different things here. And I can actually type a question. So while learners are working, learners are engaging. And now I can show this on the screen and have the learners actually have this conversation. Is this a correct representation? What's wrong with these representations, if anything? Why are these better representations, and why? And of course, as math teachers, we know that we would want to see the little arrows there. Not every learner is going to do that though, but the snapshot feature allows us to pull learner work, show learner work, compare learner work. I can put all these together so that we can have them as one. I can have them separate so that they're two. It just depends upon how we want to have that conversation with the class. So notice the Desmos activity here I've set up allows us to move from individual work to all class work in a couple of different ways. The snapshots being one of them, the overlay feature being another one. And on the overlay, I can show this to the class, and we can say, yeah, you all are fabulous. We do not need to spend any time working on this. What questions do you have so far about just a couple of the little features here that I've introduced, if any? Okay. Nothing in the chat. That's very cool. So let's keep going on our slide deck, and I will unpause. We're going to come to, I asked the question in a couple of different ways. Slide 4 wants a parabola facing down. And then slide 5 shows how I would come back to the card sort and re-engage learners with the card sort so that I'm reinforcing the idea of what I want them to really take away from this exercise. And then slide 6, I want them to actually type it out themselves. I want to see their thinking, their thought, what actually are they engaging with in the lesson. So instead of constantly only setting up the idea for them, the goal is to get that higher level thinking, the comparing and contrasting, the analysis, and really encourage learners to engage in that practice of analysis. So slides 2 through 6 are using a card sort to kind of encourage and help with that analysis. Breaking it up with some sketching is just a good practice because, again, it's about the learner producing their own work. What's also interesting, those snapshots can be used with typed responses as well. So as you give learners the opportunity to type their responses, you can pull up different snapshots of typed responses and have that whole class conversation, comparing and contrasting as well. Which brings up the interesting question, as I was designing this, is, are you all comfortable creating your own activity like this? And so do you want to see the other side of it on how to create this activity so far. Perfect, okay. So I have that also queued up here. So I'm going to hit pause so that we can come back and share my screen again. Awesome. So when you go to when you go to teacher.desmos.com, make sure you create your own account. Very important to create your own account. And then just couple little secret things here. Click on the arrow, click on Desmos Labs, and check all the boxes for yourself. Give yourself all of the tools that are available to you. Also check your account settings and just make sure your name and everything is in there correct, like you want it. But super important, click on Desmos Labs, give yourself all of the tools that are available. The other thing that we're going to do here is we go to custom activities. And I have a whole bunch of custom activities just because I've created them. But click the big blue button here that says create a new activity. And when you do that, it just looks like this big blank screen. And that big blank screen can be a little scary or intimidating. But if you think about it kind of like a PowerPoint, it works really well because there are blocks of things that you enter. So you can do a note, which is just for you to type in. You can ask for a free response for learners to type in, and you've seen a couple of those boxes already. You can require math to be typed, multiple choice, which are exactly what we would think about it. We can ask students to order lists where they have to categorize things from top to bottom. There's also edit, delete. It's incredibly flexible in that sense. You can insert graphs, sketches, media or pictures, geometry. Geometry will not be available to you unless you activate it. Tables, action buttons. So you can add and subtract and create whatever you wish. And then there's some full screen items. So when I looked at mine, the first thing I did is I said, let's enter a card sort. So I grab the card sort, drag it over, let it go. Again, it's blank, but over here it gives me the types. So I b squared, b squared minus 4ac equals. So a text card allows you to type in math by clicking here. You can italicize, bold. You can put an image, just drag and drop from your desktop or from a folder. You can enter a graph. And there's our graph. When you click preview, it'll then show you everything randomized. So creating a card sort is incredibly easy to do. And that's how I created all of the different cards for the card sort, is just one at a time. I first started with what I thought would be the top cards. And then I just went through, created graphs, created all of the text, and built it like that. If you wish, you can edit an answer key. That way the learners will know on the teacher screen. You can check the answer and you'll see red or green connections on the teacher screen. So that way you know if learners are doing it correctly. This one looks pretty good, or not. So the initial setup for a card sort is really easy. I love card sorts on Desmos because I hate card sorts with paper. I literally detest card sorts with paper because inevitably someone's going to lose a piece of paper or write on it or something. Whereas a card sort on Desmos, I don't have to manage that paper aspect. For the sketch, all I did is grab the sketch, drag it over, create a new slide here, drag the sketch over, customize the background. If I want them to have something to compare against, I can edit the graph. Click done. And so now the sketch will start with that. And then learners can have the sketch however they want to. Just depends upon what you're looking for or whether you're doing geometry, in which case I might have the background blank, or I can actually put a picture in the background and have them sketch it out themselves. Put a picture of cute kitties in there. And so now when the sketch is, you can, and there's lots of reasons to do however you want, all three different options. It just depends upon what your goal is. Same thing, I just deleted some cards and added some cards. And then finally on the comparing, I added a note, type in the note, and then I added a free response. There's some interesting things here. This little checkbox of show students their classmates' responses will randomly pull 3 student responses to show, or it will not show. That depends upon whether or not you, the teacher, want students to learn from the other students and refine their ideas, because they can always go back and edit their ideas, or whether you just want that one shot. I think there's reasons for both. It just depends upon what your individual goals are that day versus a different day. And then I entered this for you all. To do this next piece, let's play around with number 8, slide 8 for a moment, and we'll see what, there's actually some interesting math there, but then I'll show you how to construct something like that as well. So I've unpaused it. If you want to all jump to slide 8, we'll see what happens. Like really think about what's the movement of that black dot. And I'll leave the overlay on because it's interesting on the overlay. And I'll give you a moment to play. All right. And if you jump over to slide 9, slide 9 actually has the answer, because I wanted to make sure that you could see the answer. And Nalini Joshi asked a really interesting question. Is there a way the vertex could create a problem that opens upward? The answer is yes. It's just that the initial parabola that I graphed has to open downward. So I'm going to hit pause again, and I'll show you how I built these slides, because these slides are different and have some very different programming involved in them. What I did to build this slide is I grabbed a graph. And the graph takes up the whole screen. However, if you then add a note, you can add the note and the free response. So now you have the graph and other things, other elements. If you leave them, and you will just have a full graph. And this is the same as selecting full screen down from the bottom. But I have these 3 elements. I'm going to edit the graph. Notice that everything here on the left was hidden from you. It was hidden because you only had part of the graph accessible to you. I just entered the parabola. I left B as a slider, so that way you could move that around. If you create a folder, so hit the plus and create a folder, only in Activity Builder is there a feature to hide this folder from students. And we're going to see, I'm going to use that again later in another slide. But what's really interesting is that you can create that point just by entering the values in math of that point. Click on the label, and that'll show you the values of that. We come over here to that slide 9. All I have to do is change this to open down and change my signs, and now that actually will open, the parabola it makes will open up instead of down. It's very curious math that the parabola that's created by the vertex is completely independent. The equation for that is completely independent of B, which is kind of cool. Interesting on math. But that's how you would create slides like this. And then I have a fairly complex one that I wanted to show that I built off of this really bad question from the textbook. So the area of the surface of the swimming pool is 220 square feet. What's the length B of the deep end in feet? So everything's given to us. And my initial thought was, what if we don't have everything given to us? How could we model that in a much more constructive way? So I'm going to unpause. I'll tell you that slide 11 and 12 actually has some extensions of this, and I'll let you kind of play with it a little bit, and then we'll deconstruct how I built this, because this did take a little bit of effort to create. So if you want to jump to slides 11 and 12, you can play with this a little bit. in reading Marcia's question in chat. So Marcia's question is about the computation layer, and I'll show how to access the computation layer here in a second. But I will say, Marcia, yes and no to your question, and I'll get into resources for computation layer here before we leave today. I'll tell you that the answer may not all be exactly what you're looking for, to be honest, because there isn't like a one-stop shop for computation layer. All right, so let's take a dive into how I built this one. Sorry, I apologize. I didn't warn you about pausing. If you haven't played around with Desmos in class and used an activity builder in class, especially if you do a marble slides, just going to tell you, always warn your students, warn those learners before you hit pause, because I have had multiple F-bombs dropped in class when everyone's really focused and engaged in an activity and I just hit pause without warning them. And it always made me happy when kids are like, what the bleep, Waddell, what are you doing? Right? Because that means they were really involved and engaged. That's kind of fun. So this required actually some setup, but what's really interesting is if you're comfortable with the math, all we're doing is just math. For the learners, I turned off the X and Y axis because I wanted it to be blank. But for creating, I absolutely would have the X and Y axis on. I also locked the viewport so that we couldn't move it around, and so only one thing could move. So there's some additional features here in the activity builder that aren't in the regular Desmos calculator. I also did something funky here, and that's I used lists. So the square bracket, -5, (5) is a list that all at once creates the top and bottom. So if I wanted to do multiple lines, I could use 3 dots, and that would give me a list from -5 to 5. If you use a comma, you're just going to get the 2 lists. So using the list is a really fast way to draw multiple lines. And then I used a domain and a range restriction for the blocks. You can label lines with the points. If you just click label, it'll say the value. If you type in text, it'll give you the text, so that you have that freedom to use either the math or a number or the word. The other thing you can do is right here, and it's probably really hard to see, but this is the tilde button right next to the one on your keyboard has a backwards apostrophe. This is a backwards apostrophe, $, and then the letter F, because the letter F I defined, where did I find F? I defined it right here. So $, squiggly bracket F allows me to pull the value here. So that's how I can get 11.5. I didn't give you 11.5. I turned off the label, but I was arguing with myself at one point whether or not I wanted numbers or, oh no, sorry. First slide was number, second slide was another word. But so the labels, you can actually put variables into your label and have the labels change. But it's just going through to construct something like this and just putting in the math step by step. I can put it all in a folder and click hide. So I could actually put this entire screen into and let learners actually play with it and do math here on the left. I didn't want to do that, but by putting it in the folder, I was able to just really quickly and easily hide it or reduce and minimize. That's actually the same way I did. And then, because this was complex, I didn't want to redo everything for slide 12. I used the triple dots over here and I just duplicated. So you do something fairly complex for one screen, you don't have to completely redo it. Just duplicate it and edit. A lot like we do for PowerPoints and material that way. What questions do you have? Not computation layer questions, we will do that in a second. What questions do you have about creating your own activity builder and developing your own activities? So let me show you one more technique and tip for building your own activities. There's a lot of activities out here. So if I type in Desmos Activity Builder, and let's say I want, and that's exactly, Pinky's asking the questions of them. I'm going to show you. Let's do linear functions. And wow, this one looks really big. And it was created by Jennifer Williams. So linear functions, there's some self-checking. That's important for computation layer. So I'm definitely going to plus this and add it to my collections. Oh, I don't have a collection yet for computation layer. So I'm going to do that. Create new collection. Great. So now I have this collection called computation layer. There is, and I'll show you that as well, Vivian, before we're all done here, because we've only got about 10 minutes. So we're going to wrap up on a strong note of here's how to find and build, or how to find and kind of make it much easier. So I've added this to my collection so I can find it later. Collections are found over here on the left. So here's my collections, but there you go. Sorry. But I'm going to hit the triple dot this time. Instead of the plus, I'm going to hit the triple dots and I'm going to copy and edit. The copy and edit allows us to do exactly what Pinky asked. So I'm going to copy and edit. And this is now in my collection, and not my collections, but my custom activities. Notice the title says copy of. And forever now, as I edit and change, this will say created by Jennifer Williams, edited by Glenn Waddell. So that way the record and the record of who created it and who edited it will always be there. And now I can go through, because maybe in your class you're using, let's see if there's some language here that we don't want to use the word correct. We want to use a different word. We want to say yes. The word yes will appear when your answer is right. So you can go through the entire slide deck of the activity, edit, change language, change however you want. However, the computation layer is how the word correct will occur in here. And if you see up here, this is named slope 2. That matters because this is the computation layer. No, Amelia, you can create and keep it private. So I'm going to click on this little bar here, and here's documentation, and the blank space here is the computation layer. So I'm gonna, and you can see how this is white, but this over here is teal. Here's actually all of the computation layer code to put in the word correct when they figure out the slope is correct. It's all it takes is those 2 lines. But what this means is, and this is important for Marcia's question. So Marcia Googled and found the computation layer documentation. This is the best place to find, and it's just teacher.desmos.com, computation layer documentation. This is the best place to find the resources that Desmos has created for computation layer. However, one of the easiest ways to really understand is to find a computation layer, find a activity that does what you want it to do, and kind of go through and play. Hopefully the person will follow good practice and document their code. There's some components over here that will help explain. And just look for these little elements here as you go through. You can see how not every slide here has a computation layer, but some do. Some of the coding is fairly small, and some of the coding is larger and more precise. But you can go through and edit everything that anyone has done. So you absolutely do not have to build from scratch. You can find those activities that are really solid, really interesting, really good. Take them into your own account and edit them to your heart's delight. And that gives us, like, I know we're done at 1:40, so we have just a couple minutes. What else can I help with? What else can I show? Yeah, Marcia, I think that's really important. Don't think you have to code from scratch. There's a whole bunch of self-checking activities that other people are making. Find them, find an activity that you really like, and you can just edit that activity and make it your own without needing to do it on your own. So there's 2 different ways to search for activities, Carrie. The first way is with this search button up here, or search box up here. So I'll search for linear functions. The problem with the search box on Desmos's website is this search box will only search Desmos activities. So these are curated, incredibly high quality. If you wish to search and find activities that anyone else has made, just do a Google search and include the word Activity Builder or Google Classroom in your Google search. And you'll find many, many activities that other teachers have made. And Ivan Chang, all you need to do is hit the triple dots, copy and edit, and it's yours. Yeah, I oftentimes will search for teachers' activities, find one that does what I want it to do, and then improve it, give it my own spin, and not try to not try to create it myself, because it's far too much effort to create it yourself. What other questions? I'm not sure about Nearpod. I haven't used Nearpod, so I don't know. I'm sorry for not knowing that, but Nearpod is not something I have a lot of experience with. That runs us up into 1:40. It's such a fast conference. I hope all of you are enjoying and finding things that you can use here. And if you ever have any questions, please feel free to reach out. I'm more than happy to help.
Thank you very much, Glenn. We appreciate that you introduced us to the world of Desmos and a lot of activities and functionalities that has been exposed to us. And we would like to thank you for sharing this information with us.